We're on lesson 1-9 today, and we're going to learn about average and instantaneous rates of change. Okay, to find the average rate of change, we're going to use difference quotients to express it, and then for limits, we'll find the rate of change at a point. Okay, so given this example here, we have a child growing up to a man at age 20, and that's his age, and your y-axis represents the height. So if we look at his age, the question says from 13 to 18, which is indicated here, okay? And then if I ask you what his growth rate is, how could we find that? Okay, well, a rate of change is another word for slope. So we could just use the slope formula and find his rate of growth per year, okay? So if you take your 2 points, 1357 and 1876, okay, from the graph, and then we find the slope. Well, you're doing subtract the y's over subtract the x's, okay? And that would give me 18 minus 13 all over 76 minus 57. And that would give me 5 over 19, okay? And so that is the slope there. So he's growing 5 over 19 inches per year. Okay, that's his rate of growth. Okay, so then, next question. What if we wanted to calculate his growth rate at the instant he is 13 years old? Okay, we're gonna do that as we move on, but at the instant it wants to know how fast he's growing. We will be finding the instantaneous rate of change. Okay, and what we found above the slope here was the average rate of change. Okay, we'll talk more about instantaneous as we move on in the notes. Okay, so secant and tangent lines are important in finding rates of change. A secant line through 2 points on a curve is a secant line to the curve, is right here, to the right. Okay, so it's not hitting the curve, it's going through 2 points. And in this case, A and B, that's called a secant. So we're gonna use these 2 points to find the average rate of change by finding the slope of that secant line. Okay, and a tangent line is a straight line that touches a function at just one point. So if you look over here, a tangent would only hit the curve once at that point, in this case A. So this tangent line represents the instantaneous rate of change, and we're going to use a limit to find out what that is. All right, but first let's do some average rate of changes, which shouldn't be too hard because it is the slope. However, you're not going to be given points anymore, like a y2, y1, x2, x1. You're going to be given functions. Okay, so it's a little different, but it comes straight from the slope formula. All right, so you should already know the slope formula is the change in y over the change in x, but we're really going to use this formula all the way to the right because we're given functions now. We're not given x1, y1, x2, y2 points. We're given functions, okay? So, for example 1, let's find the average rate of change of f of x equals x to the third minus x on 1, 3, okay? So 1, 3 is my interval. That would be A to B. So wherever I see A, that's representing 1, and wherever you see B, that's representing 3. So we have B and A, but we don't have f of B and f of A yet. So that's what we're going to have to find. All right? So f of B would be f of, hold on. Let's just find f of A and f of B first. Okay, so f of A would be f of 1. So we're going to go to the function and plug in 1. So it would be 1 to the third minus 1. That would give me 0. All right, f of B would be f of 3. So that would be 3 to the third minus 3. And that should be 24. Yeah, 24. Okay, so now we know what f of A, which is 0, f of B, 24, what those are, and then when we know what A and what B are. So we can plug it all into the function. Okay? All right, so we have f of B minus f of A all over B minus A. Okay, so now that we plugged everything into the function, we really do have our points. F of B comes first. So f of B is 24 minus f of A 0 over B 3 minus A 1. Okay, so that's 24 over 2, 12. Okay, so the average rate of change between 1 to 3 on that function is 12. Okay, and you can kind of think about it, that what was the change in y? 24. What was the change in x? 2. So what would their average be? 12. Okay? All right, so example 2. Find the average rate of change of f of x equals e to the x minus 1 on 0, 1. Okay? So first we need to find what f of A and f of B are. Okay? F of A would be f of 0. So that would be e to the 0 minus 1. Okay, that's e to the negative 1. Which is just 1 over e. Let me see what f of b ends up being, because we might change those to decimals. All right, let's see what f of b is. That's f of 1, which is e to the 1 minus 1. E to the 0 is 1. Okay, so let's still plug this into the function. We might change 1 over e to a decimal. Let me see how it works out. And then we have a and b are 0 and 1. Okay, so I'm going to write the function, then plug everything in. So f of b minus f of a all over b minus a. Okay, so f of b was 1 minus 1 over e is f of a. All over b is 1 minus 0. Okay, so that's 1 minus 1 over e divided by 1, which is 1 minus 1 over e. Okay, now you may see that as an option. However, if you don't see that as an option, like it's not multiple choice, you can always plug it in the calculator and see what you would get. So 1 minus, I'm going to do my alpha y equals enter. 1 over e is like pi. There's actually a value for it. And it's right above the, sorry for the dog hair. It's right above the divide sign there. So that's 0.632. Okay, or 0.632. Okay. All right, cool. Last one, find the average rate of change. F of x equals cosine x on 0 to pi over 2. All right, so we have a is 0, b is pi over 2. F of a is f of 0, and that's cosine 0, which equals 1. All right, and f of b is f of pi over 2, and that's cosine pi over 2. All right, so when you put it in your calculator, unless you know what that is, cosine pi over 2 equals 0, okay? If it doesn't, make sure you're in radians, go to mode, and make sure you're in radian, not degree. All right, so that's 0. Okay. So now we have everything we need for the function, or for the formula. Let's plug it in. F of b minus f of a all over b minus a. F of b is 0 minus 1 all over pi over 2 minus 0. Okay? So that's negative 1 over pi over 2, which ends up being negative 2 over pi. You would really times that by 2 over pi. Okay, negative 2 over pi. All right, that's it for the first page.